Okay, so now I'm going to tell you a bunch of things that you've already heard before, but it all relates to this Kw value, which is pretty interesting. So you're going to be calculating pHs and pOHs. I've given you those formulas back. All right, have them written down somewhere. I'm reminding you in pure water that pH is 7, pOH is 7, right? And pH plus pOH equals 14 in any solution. You've seen that before, but now you know that comes from Kw. Remember? Because if you do, check it out, negative log of Kw, you get 14. So any solution adds up to 14, those pHs and pOHs, just because of how water ionizes. All right? And Kw, this OH times H3O concentrations equaling the same number, is valid for any system containing water, which you might think is limited, but check this out in all caps. That's everything that's aqueous. So Kw, we're going to use a whole bunch, usually just with acids and bases, but it's super, super useful. Okay, and you've actually been doing this in Science 10 and in Chem 20, right? But it all comes back to just the behavior of water spontaneously ionizing, just a little bit. Okay, I've set up an example in the back here. There's a funny typo. So I'm giving you a solution of acid. There's the H3O concentration. We're going to determine pH, pOH, and the hydroxide concentration. You can actually do any of these first. Okay, there's no right way of doing this. There's methods. They all work. I showed you them earlier in this video. Okay, so let's find the pH quickly. Let's remind ourselves how. pH is negative log of the hydronium concentration. So I'll write all that out. But that's just negative log 0.10. Okay, and I think we're going to get a nice number here. So just, if you haven't done this before, I hit negative, just this log button. And I knew it. This has got a pH of 1. Okay, different ways you can get pOH, but probably the simplest one is that these guys have to add up to 14 in every single solution. And again, that value comes from Kw. Okay, so remember, a low pH is acidic, a high pH is basic, and then pOH goes the opposite way. A high pOH is acidic, and a low pOH is basic. Okay, here we go. The last thing, find OH concentration. We could use Kw. Let's do that. So I'll just remind you over here, Kw equals H3O times OH. Just because I don't think you've seen this yet or used it yet, I'm not going to use negative log OH concentration. I'm going to use this. So OH concentration is just Kw divided by H3O. Okay, so Kw, just a reminder, have that written down somewhere as well. It's just 1 times 10 to the negative 14. Divide by that H3O concentration. Okay, and we're going to get 1.0 times 10 to the negative 13 moles per liter. Okay, so this is the type of math I can ask you on today's assignment.